Hi friends, welcome to the Matrices lecture. This lecture will be completed in roughly means any number. I can say give you the numbers. The deep we go, the more will be the discussions. But mind it one thing, I won't waste your time nor my time because I won't be wasting the time on some creepy discussions which are given in the textbooks. Okay, so we'll directly move on, cover the main parts. Okay, whatever is required, not only in the exam, from whatever is difficult, that's what we'll be covering. Mainly we'll try, of course, I'll cover the complete lecture, complete matrices will be covering, but I'll focus more on the difficult part. Okay, so let's move on. So let's start with the first lecture on this. See this. First is matrices. Now definition and everything, I'll just explain you this concept. What is matrices basically? This matrices means basically it's arrangement. Arrangement of what? Arrangement of various two separate elements. Okay, sales versus time, or city versus this method of mode of movement. Okay, see this example. First one, city versus factory means there are, let's say, 1 2 3 4 cities. There are, let's say, 1 2 3 4 factories. How to match these? Go from year to year. You'll explain it, you'll understand it better in the next example. Okay, so look at this. From here you'll understand it better. See this, in this game there are two players. Let's say, game theory, consider the coin matching game in which two players participate. See this, coin matching game, head head, tail tail, right? Now what is the game? Each player calls either a head or a tail. If outcome is head and head or tail and tail, A wins, rupees 100 from B. Now understand this. What is this concept overall? Two players are playing. Okay, I'll say both will be heads. You say both will be tail. Okay, so, or second thing is here. Let me make it simpler over here. I'll say both will be head and head, or both will be tail and tail. Understand whatever I am saying. Everyone kindly understand this. Okay, what am I saying? Say this. I am saying A is saying A. Either it will be head and head, and or it will be tail and tail. That's what I am saying. Head and head or tail and tail. That's what A is saying. What is B saying? B is saying no. Forget this. Head and head, nothing. Nothing will be like this. Either it will be head and tail or tail and head. Anything, but nothing common. Now, how do you represent this? How will you put this in the picture? Suppose if you have to explain it to the computer in the programming, how will you explain it? So in that case, we need this matrix. We'll be needing this matrix. This matrix over here means, look at this. This means that, look at this. A is saying head and head or tail and tail. And B is saying what? B is saying here, if A wins, means if it is head and head, then B will give 100 rupees to A, or rupees, dollars, whatever. B will give $100 or rupees to A. If it is tail and tail, then also B will give. Understand this. I am A. I am saying that head and head or tail and tail. So if both of them, if I win, then you pay me $100. Or if it's a second case, then I'll pay you $100. So this is represented like this over here. Okay. A says head and head. So B will pay, it will be plus 100 for A. Right? Plus 100 for A. And tail and tail, again plus 100 for A. You are able to see this now? Yeah. Second case B, head and tail. So it is minus 100 for A. It is plus 100 for B. And similarly, tail and head, minus 100 for A. So it means plus 100 for B. Game theory means here. What is a game theory? Game theory is of two types of game theories are there. One is two-player game theory and second is multiplayer game theory. Two-player game theory is very easy. Two-player game theory means what? There are only two persons. If one loses, other one wins. It's very simple. One person's loss is other person's profit. That is two-person game theory. And three-person's game theory, you don't know. Three-person's game theory, the simple rule is play with the least losses. Everyone, every player, because you don't know. One person's loss may not be other person's profit. Because there are multiple players over there. Someone else's profit might be there. Out of 10 players, one might profit, but nine might lose. So that's why for game theory of multiple players, the rule is play with the least losses possible. Okay, move on. We are not in game theory over here. We are here for matrices. Okay, so move on. So A, you got it. This is how it will be represented. Now this representation of this, it means what? Now we come to this definition. What does this definition say? See here. Understand the terms over here. You are not going to learn this definition. The terms over here are A means what? Simply collection. It's array. Array means this. Say this. Arrangement of certain numbers in an array of m rows and n columns. M rows, n columns. Now what is m and n? It can be anything. 5, 10, 15, 20, 100, 1 lakh. 1 crore, 1 billion, 1 million, anything. M rows, what are rows firstly? What are rows? All these are rows. See this. All these are rows over here. This one. This is a row. This is a row. And what are columns? These are columns. So this is a column. This is a column. M rows, n columns. It can be 2 by 2, it can be 2 by 3, it can be 3 by 2, anything. Any combination is possible. Okay? So the point over here is, what is this? You need to understand this M and N. So move on. Now look at this. A is known as a matrix A. This A matrix is M by N. What is M by N? M rows and n columns. Row is always first. Kindly note this very simple logic over here. Row is always first. Okay, M by N. Row will always be first. Okay, so rows into columns. Kindly note this. Row into column. Always it will be like this only. Row into column. Okay, so A equals to, say this, M by N. A M by N means it is written as A M by N. So what is A? Now this small a over here, which is shown over here, small a, you are able to say this? Let me expand this if possible. Yeah. So this small a over here, Aij, it is written as Aij. Okay, what is this Aij? Aij is each one. This one. Everyone is Aij. Okay, this Aij is everyone. It means what? I is what? I is number of rows. Kindly note, rows, columns, rows, columns. First is rows. Second is columns. Okay. So Aij. Got it? Aij. I means what? It can be 2 by 3. It can be 3 by 2. You can look at this. Look at this. See this. Aij. So each element is A, small a. And big A is what? Complete name. It means what? This is the father of the family, or this is the family. Why father? Why we patriarchal? So let it. This is the main family, and these all are the members. Okay. So Aij, M by N. M is rows, N is columns, small a is element, Ij is each number. Suppose if I want to write now, I want to show this. Okay, let me show this. Suppose if I want to show this number 2, what is this 2? How will I show this 2? So it will be A. This A is what? A first is what? Row. What is the row? 1. And what is the column? 2. So 1, 2. It will be shown as A12. Okay, A12. That is how it will be shown as. Suppose if I want to show this, what? Let's say 1. This one I want to show. How will I show this? 1. It will be, you write, you tell me everyone. A. And now what is this? Row. Which row? 1, 2. 2. Which is this column? 1, 2, 3, 4. 2, 4. A24. So this 1 is A24 equals to 1. I can write it like this. A12 equals to this 2. This is the meaning. Got it, everyone? Clear this term small a and capital A. Now let's move ahead. Okay? One second. So got this point, everyone? Let's move ahead. Now remaining all this discussion I won't do. We'll be directly moving ahead with the important parts. Rows and column matrices, type of matrices. Here we'll directly focus on what is important over here, because remaining thing you can study. When by study you can definitely grasp through this. Okay. So rows or column matrices. What is row or column matrices? A matrix of the order 1 by n or having only one row and n columns is known as row matrix. Means what? Only one row. See this one, this part. One row, only one row. Clear? This is simple. See, simple terms will move fast. What is the column matrix? Reverse. Okay, only one column, many rows. So how will I write this row matrix? Suppose if I write like this, let's say B. Okay, I'll write like this. Let's say okay. B, I write it B15. What can you say? Is this a row matrix or column matrix? B15. You tell me. How many rows are there? 1. So row matrix. B15 is a row matrix. If I write like this, B61. What is this? Column matrix. 6 columns, 1 row. 6 rows, 1 column. Isn't it? Column matrix. Clear? Next. Next, row column clear, null matrix. What is null matrix? Everything is 0. Okay? Everything is 0. All the elements are 0. Clear? Every element is 0. A matrix containing all 0 elements is known as 0 or null matrix, and it is denoted by Z. Kindly note this. Z. Whenever you get this word Z, alphabet Z, it's basically you are talking of null matrix. You will say, why do we require null matrix? Don't think about it. Okay, what is given, just think, just read this. Okay, don't think why do we require this, why do we require it, everything is 0, why do we require it? Let's keep it for it, keep this for later. Do you see the whole film in 1 minute only? You see the film for around 1 or 2 hours, right? So keep some suspense. Let's move on. Next, 0 or null matrix done. Square matrix. Square matrix means square. What is square? Same row, same columns. Okay, containing number of rows equals to number of columns is called a square matrix. Clear? Simple. Next, transpose. Now focus on these terms. Now these are difficult terms coming up. Okay, focus on the terms. Transpose. What is transpose? Transpose. Matrix obtained by interchanging rows and columns of a matrix A is called as the transpose of matrix. Interchanging rows and columns. What do you mean by this? See this. A is a matrix. Now you tell me, everyone, take pen and paper in your hand. How do you write A over here? Tell me. How do you write A? Yeah? How many rows, how many columns? I want order of A. Okay? So A, how do I write this A over here? This A, how will I write this A? A will be, how many rows and how many columns are there? Look at it. This I'll have to check it, how to work on this. How many rows and how many columns are there? Look at this. Symmetric is further. Now we are on transpose. say this transpose. How many rows and how many columns are there? 4 rows and 3 columns. So how will I write the order of A? The order of A is what? A 4 by 3. Correct? A 4 by 3. Now what do you mean by transpose then? In transpose, when A 4 by 3. Okay, this is my matrix A. Now if I want transpose, what am I doing? In transpose I am reversing this. It will be 3 by 4. Look at this. It will be 3 by 4. Say this. 3 rows and 4 columns. 3 rows and 4 columns. So AT is what? AT equals to 3 by 4. 4 by 3, 3 by 4. Okay? So rows become column, column becomes rows. Transpose. Clear? Done? Simple? Move on. Next. Symmetric matrix. Symmetric. Symmetric means what? Both. Everything is same. So it means this. What do you mean by symmetry? Our body is symmetrical. Left side equals to right side. Symmetrical. Whenever you see the mirror, symmetrical. Two types of symmetry, bilateral and radial. Remember this na, in your school? Two types of symmetry, bilateral, radial. So, symmetric. Say this. Here you will see the elements are same. The square matrix is said to be symmetric if A equals to A dash or transpose. So if A equals to A dash, transpose and the main matrix are same, then it's called a symmetric. Means what? See here, can this be symmetric matrix? This one, A. Can this be symmetric? No. Why? Because if I change this, it's not same. Are these two mirror images? No. What about this? 1, 2, minus 1, 2, 1, 3, minus 1, 3, 2. If I change this, 2 comes 2 over here, transpose. See this, I am changing this. So what will happen? See this, it will become the same. Suppose if I change this, column will become rows, rows will become columns. So 2 will come over here, minus 1 will come over here, 2 will go over here. So same thing, it's not changing at all. Right? So what does it mean? If your Aij equals to Aji, now this is important term. Aij equals to Aji means what? Aij equals to Aji. It means this, say this. Aij, okay, let me write this Ij. First one, let's write it for 2. What is the, how will I write this 2 over here? A2, second row, and which is the column? First column. A21 equals to, now look at this one. Aji, A, which is this one? Row is first, 1, and what is this column? 2. So A21 equals to A12. Same thing for everyone. Look at this minus 1, look at this minus 1. Look at this 3, look at this 3. Only leave this diagonal. Leave this diagonal and everything is same. Symmetric, mirror. I'll put a mirror over here. I'll put a mirror over here. Everything is same over here on the both the sides. Okay. So when you have this, this is called as the symmetric matrix. Means your matrix equals to transpose. Keep it very simple. Your matrix, main matrix, main equals to transpose. When you have this, transpose. Okay? When you have this, main equals to transpose. At that time it is called as symmetric matrix. Okay? Symmetric. Okay? More on this later in the next lecture. Enough. Okay?